Hello and welcome back to another video tutorial on Would-Be plugin. Would-Be is a Grasshopper plugin that helps you to extract toolpath for CNC or robotic milling from geometries in Rhino. So in the previous video, we got to this point, which we have extracted the rough cut and a fine cut from this set of geometry that I have shown here. And we use the planar sheet milling tool, which has a sort of AFD feature, the automatic feature detection, which basically extract different features from your geometry that can be milled with certain strategies. And today we're going to focus on a few aspects of these toolpaths and try to improve them. Because if you are an expert in the area of machining, you probably know that the toolpath that we have created in previous video may not give a good result due to some certain properties that we're going to address today in this video. We start with the rough cut and we try to improve it. So I'm going to just disable this too, and we can look at our rough cut. Now I'm also going to change my geometry color in order to see the toolpath better in the viewport. So let me change it to black, and I'm going to also turn off the table. Okay, so the toolpath shown in three different colors. The first is the red, where the toolpath moves above the object, and that's what we call it rapid feed or traveling. In order to set the speed in which the tool is moving, we can use the settings under feed and speeds from the would-be general settings. And here you can see different parameters. One is the work fit. The work fit is where the toolpath shows in green, and the tool is actually engaged with material and is basically doing the work, which is milling. And the speed for that at the moment is 1000 millimeter per minute. So this is obviously something you have to decide based on your tool, the material you're milling, and the machine that you're using. So I'll leave that up to you. You have to look at the catalogs of the tool. What is the recommended feed based on the depth of cut? The other important speed is the movement above the geometries. In this case, we're moving in a plane. So if I look at it from the elevation, all this movement are within a plane with a certain offset. And we're going to see how we can adjust this plane later. But right now, we're interested in the feed for the rapid movement, which is right now is 4000 millimeter per minute. That's again based on what machine you're using and how fast it can go. And the other two important feeds here, which are in your toolpath shown and in yellow color, is where the tool is actually going to engage with the material or retract from the material. So these are set in a percentage, and that means that the speed which tool is going to engage or retract with the material is going to be 75% of the work feed, so the value that you're going to set here. By the way, you have two options for work feed and for setting the speed. You can also setting it based on the millimeter per revolution of the tool, and that really depends on what you set in the spindle. So right now I have 1 meter per minute, or you can also set it per revolution per minute or RPM. So you have I have it as a default 24,000 RPM. It's 24K. And if I choose millimeter per revolution for work feed, then it's going to calculate the speed based on the diameter of your tool. So these are the options that you can set up your feeds, and I'm going to keep that video short, and we're going to talk about the milling strategies and depth of cut in the next video. Thanks for watching, and see you in the next video.